In this video, we'll learn about the all-important Java method. If you're an experienced programmer, you've probably run across functions in the past. In Java, the terms function and method are basically used interchangeably, with method being the more technically correct term that you'll see in documentation. Methods are a tool that allow us to break up the control flow of our program. They let us declare little subroutines, or sometimes we can think of them as smaller programs that we can reference in our program so that we don't have to write absolutely all of our program's logical code in one single block. An example of a method is the .next method found in the scanner class. Rather than having to teach our scanner object how to acquire the next set of user input in this program I've written, I can simply call the next method from the class that someone else has written in the past. This turns what would probably be a couple hundred-line program into the 22 lines we have right here. By writing our own methods, we can tackle complicated challenges by breaking them into much smaller and easier to manage parts. Programs that are properly modular and make use of methods are also much more human readable. Because we can give our methods our own names, our program can be much more self-explanatory and make use of a lot more English, or whatever language we are native to, words. To show you the power of methods right from the start, I've planned a pretty complicated program for us to write today. Our goal is to create a temperature conversion program. And I've set up the input portion of this program for us already. So far, this program takes 3 pieces of information from the user. A temperature type, these being F for Fahrenheit, C for Celsius, and K for Kelvin. Then it takes another temperature type. This is the type that our user would like us to convert to. Once again, Fahrenheit, Celsius, or Kelvin. And then we get from the user the value of their initial temperature. Our program with these 3 pieces of input will convert the given temperature value from Fahrenheit, Celsius, or Kelvin to Fahrenheit, Celsius, or Kelvin as the user desires. This is a challenging program for 2 reasons. First, there are 6 possible control flow cases because there are 2 sets of 3 user inputs. That means, worst case scenario, we might have to write 6 if-else blocks, which will get unwieldy pretty quick. The second challenge is doing the actual conversion. I've gone ahead and looked up the conversion math for 3 temperature conversions: Fahrenheit to Celsius, Celsius to Kelvin, and Kelvin to Fahrenheit. As you can see, while this isn't difficult math, it's certainly unwieldy, and our programs are going to look pretty crazy if we start copying and pasting formula like this all over the place. I should also note that with these 3 conversions, we can make any of the possible conversions this program will be asked to do, because these 3 conversions create a circle of conversion where we can get from any type to any other type by possibly passing through one of the interim equations. With that all said and done, let's just jump right into writing our program. The first thing we need to do is set up some control flow. As I mentioned before, there's 6 possible cases, and it might be tempting to just set up 6 if statements for each possible pairing of input and output types. That would be a little unwieldy though, and so I have a slightly different plan. Instead of handling a different case for each possible pairing of types, the first thing I'm going to do is convert whatever value our user has given us for the initial temperature value to a Celsius value. Then after I've done that, we'll convert that Celsius value to whatever type the user was originally looking for. This has the advantage of letting us deal with the two pieces of user input in complete isolation. It makes our program more modular because we start and finish one task before we begin the next one. So to do this initial conversion, where we take whatever the user has given us as input and convert it to a Celsius value, I'm going to utilize a switch statement. We'll be switching across the input type character variable, which tells us what type of temperature, Fahrenheit, Celsius, or Kelvin, our user has given us. Inside the switch statement, we'll be manipulating the input value, in which is stored the value of that temperature. So I guess we're going to need separate cases for each of the possible or valid input types. That is capital F for Fahrenheit, C for Celsius, K for Kelvin, and we should probably also handle a default case. Let's start off by writing that default case. We'll use system.exit, and we'll exit with code 1, which is technically an error code. System.exit basically quits our program. It tells it to stop executing, and it passes to the operating system or whatever's up in the hierarchy this code here. In our case, our program will just stop. So that's because in this default case, we only expect to enter it if the user has failed to enter F, C, or K, which are our valid inputs. Now, let's go ahead and handle each of these input types. We're going to use Celsius as our first convert to in all cases. So if our user has inputted a Celsius value, we can just go ahead and break out of this case because the value of input value is already A-OK with us. Now, what if the user has given us a Fahrenheit value? Well, let's scroll up to the top and we'll see that we have the explicit conversion from Fahrenheit values to Celsius. We can take this block of code, which I've made pretty Java friendly, and let's just change the value of this input variable to the conversion statement run on its value. So we'll replace this T placeholder with input variable. And that will properly store in this variable the Celsius equivalent of our original Fahrenheit value. We can do something similar for the Kelvin case. However, we don't have an explicit conversion from Kelvin to Celsius. But we do know how to convert Kelvin to Fahrenheit and then how to convert Fahrenheit to Celsius. So we can get away with doing something like this, converting our Kelvin value to a Fahrenheit value, surrounding that in some parentheses, and then doing our Fahrenheit to Celsius conversion on that. Now, this is technically a functional line of code. If we run our program and enter a Kelvin input case, this will properly convert the Kelvin value to a Celsius value. But let me say that if I'm a programmer and I'm at work and I run across a line of code like this, especially a line of code like this without any comments explaining it, I am not going to be very happy. There are a whole lot of magic numbers in here. That's numbers or really information in general that's not in any way self-explanatory. Sure, we as the original programmer, at least when we write it, remember that our goal here is to convert a Kelvin value to a Celsius value, but that's really not understandable for anyone else going through this program who doesn't really have time to sit down and look through the entire thing. So, is there a better way to do this? Yes, there definitely is. Let's return to our Fahrenheit input case. This line of code is a little better than our Kelvin case simply because it contains fewer numbers, but it's still not programmer friendly by any sense of the word. So, what if in our initial implementation of this program, we could provide communication that really looked a lot nicer to a programmer? What if we, instead of printing out that equation right there, put the equation somewhere else in our program? And instead called a Fahrenheit to Celsius function. We'll just type in F to C now to keep things short. That makes a lot more sense to someone looking at our program. We can do something very similar down here for the Kelvin case. We could call a Kelvin to Celsius function if we wanted to, or if we don't even want to write that, we can call a Kelvin to Fahrenheit function on our input value, and then call this F2 Celsius function on top of that. That's what we did with all that math initially, conceptually, except that what we've done is abstracted away those numbers and put them somewhere else in our program. This is much more friendly to a programmer. And let's say we made a mistake in our math and another programmer wants to go through and check it. All they need to do is find these functions that we're about to write, and they can dive into all their dirty details there. So, of course, we do need to write these functions. When we create a new function, we're actually going to do it outside of the function or method that we're currently in. Currently, we're in our program's main method, which is a special method where the program begins its execution. So, to write our Fahrenheit to Celsius function, we're going to step out of that method and declare a brand new one. Essentially, we're teaching our program how to run a new program called F2C. For now, go ahead and use the public static keywords in front of your methods. These keywords are going to be very important once we really jump into the object-oriented nature of Java. But for now, we'll utilize them on all methods we declare. Your standard Java method also has one more keyword before we actually give it a name. And that is the type of information this method is going to return. For example, we would like to be able to call F2C on our Kelvin to Fahrenheit function. When we do this, we're basically treating the result of our Kelvin to Fahrenheit function as a floating point variable of its own. This is a good sign that the return type we're looking for in these functions is float. What that means is when these little programs finish executing, they're going to spit out to our main method that called them a floating point value. After we name a function, we follow it with two parentheses in our function declaration right here, that is. Between these parentheses, we're going to tell our program what information this function is going to require to run. We do that by basically creating some variables right here. We're going to want a variable that I'll just call initial val. Actually, let's call it fval because we're starting with the Fahrenheit value. And we also need to tell our program before each input variable what type of information that's going to be. That way, people can't improperly call our function and pass in something like a string that wouldn't make any sense. So we're going to tell our function that in order to run, it needs to be called with a float piece of information given as input. In the functions that we wrote before they actually existed up here, you'll see that we did that. We provided input value, or the value of the temperature the user initially gave us, as input to these functions. Now, we need our F to C function, our Fahrenheit to Celsius function, to perform some computation on this fval variable right here, which will contain the user inputted temperature value. Since we're going from Fahrenheit to Celsius, we can just copy and paste this string in again and substitute f value for T. Now, it may be tempting for us to ask our function to perform this operation right here, to change the value of this variable. While we're certainly allowed to do that, it's not going to give us the result that we require. When our program hits line 27 and runs our F to C function, giving input value as its input variable, this variable is not actually going to drop down to our function's line of code. Rather, Java is simply going to copy the value of input value and store it in our new variable here. So changes we make to this f value variable will not map to our input value variable. Fortunately, we explicitly change the value of input value to be whatever this function we're writing now returns. Once we're ready to quit execution of a function, we can have it spit out any value that's equivalent to the value type that we told Java this function would return. We do that with the return keyword, followed by any statement that computes to, in our case, a floating point value. So when our F2C function run on input value returns, it will print out a floating point number equivalent to the Celsius value of our initial Fahrenheit value stored in input variable. Once we've written one of these functions, writing other similar functions becomes pretty easy. To write our Kelvin to Celsius function, we're simply going to do the same thing, but in this case, take our Kelvin to Fahrenheit function, but in this case, we'll take our Kelvin to Fahrenheit conversion equation, change the name of our variable. We could call it fval if we wanted to, but kval is just more explanatory, and return that result. So that's the first half of our program, where we convert whatever the user has given us into a Celsius value. So far, this has been much more elegant than 6 if statements, but we have only written half of our program. Once we've done the Celsius conversion, we're going to want to use another switch statement, this time on output type, where the user has told us what temperature type they'd like to see the equivalent value of, or see the equivalent value in. I just noticed we missed a break statement there. And our cases are going to look very similar to our first half switch statement. However, here, instead of converting everything to Celsius, we're always going to be converting from Celsius. Once again, that means case C can simply break. In any instances where we've converted to Celsius and then no longer need to convert from Celsius, we're good to go. Now, our explicit case here is now the Celsius to Kelvin conversion. We know that formula, thanks to our nifty cheat sheet here, and we can build a function to do that pretty quick. So that function we'll call C to K. There's our variable name, and there's the logic. Once we've declared our C to K function, we can call it on input value here, since input value now stores the modified original input value, which will be a Celsius number, to convert to a Kelvin value. Similar to the way we doubled up to convert from Kelvin to Fahrenheit to Celsius when we were making everything Celsius, we can get a Fahrenheit output by getting a Kelvin value from our Celsius value input value, and then using Kelvin to Fahrenheit, the function, to convert that Kelvin value into a Fahrenheit one. And that's the second half of our program. Still only 2 real lines of code that might cause anyone to pause, and they're pretty self-explanatory. Yet, all of the logic and functionality of our program is still accessible to a curious programmer who wants to re-access them. We can finish up our program here by using println to spit out input value, which should now contain the proper conversion. Let's run this program and give some inputs and outputs to see how we did. So when we run our program, it asks what input type we're going to give it. Let's give it a Fahrenheit value. We would like to get a Celsius value. And let's see what the Celsius value of 32 degrees Fahrenheit is. And we get the output result of 0. 32 degrees Fahrenheit is 0 degrees Celsius, so that's a good sign. Let's try some more edge cases. If we attempt to convert Celsius to Celsius, we get the same value, which is what we would expect. And let's see what the Fahrenheit value of 1 degree Kelvin is. And good news, that's also the expected value there. So there you have it. We've employed functions to make an otherwise very complex and difficult to read program much, much more manageable. The program we've written here is somewhat complicated. It does some math and some multifunction statements. So if you weren't 100% with us the first time through, I encourage you to go back and check what tripped you up. There's also other ways to approach this problem, and if you had a stroke of inspiration, I encourage you to explore it. Thanks for watching, and I'll see you next time.